Geometric dimensioning and tolerancing. Introduction. In manufacturing, quality is paramount, costs must be controlled, and the processes must minimize waste and use resources wisely. To reduce cost, many component parts are currently being sourced from suppliers all over the world. The need for accuracy in part design and manufacture is greater now than ever before. It is imperative that the design intent and functionality of the part be clearly communicated between the design engineer and the manufacturing plant. Geometric dimensioning and tolerancing, GD&T, is a precise language of engineering symbols that clearly communicate the design intent of the part. The result is an improvement in communication and part quality. The GD&T methodology is currently used in automotive, heavy equipment, aviation, and several other industries. History. The origin of GD&T has been credited to a man named Stanley Parker, who in 1938 developed the concept of position or true position as it is referred to today. Mr. Parker, by all accounts, worked in a munitions facility in Great Britain. During his time there he encountered parts for torpedoes that were rejected when inspected using traditional tolerances. However, he found that many were functional parts and were being sent to production even though they were technically out of specification tolerance. Upon further investigation, he determined that the standard XY coordinate tolerances resulted in a square tolerance zone. Some of the dimensions of the working parts fell slightly outside of this zone but were within a circle that encompassed the square's corners. He surmised that if the corners were in spec, in most cases the parts that fell within that circular zone resulting from the application of the same tolerance were just as functional. Mr. Parker would later publish a book in 1956 entitled Drawings and Dimensions. Mr. Parker's determination of position, or true position, has since grown to include other concepts including flatness, profile, runout, roundness, and much more. The concept of GD&T was adopted by the military in the 1950s and is now in use in multiple industries around the world. What is GD&T? Geometric dimensioning and tolerancing, GD&T, is a language of symbols used to describe a part's nominal geometry and the allowable tolerance for variation. When applied properly, the design engineer can concisely define a feature's location, size, shape, and orientation on the part. GD&T is intended as an addition to the coordinate dimensioning system, not as a complete replacement. The GD&T methodology takes into consideration the function of a part and how that part functions with related parts. Therefore, for proper application of GD&T you must have a thorough understanding of the function of the part within an assembly. GD&T has established standards used throughout the world. The proper application of GD&T is defined within an American Society of Mechanical Engineers, ASME, standard used primarily in the United States, and within an International Organization for Standardization, ISO, standard used by many European countries. Type of tolerances. We will be going to discuss specifically about GD&T. Example of GD&T. Different GD&T characteristics. GD&T characteristics. Other important symbols. GD&T characteristics. Feature control frame. Reads as: the position of the feature must be within 0.02 diametrical tolerance zone at maximum material condition relative to datum A, B, and C. GD&T characteristics. Feature control frame. 1. Leader arrow. This arrow points to the feature that the geometric control is placed on. Extension line or no line is shown. 2. Geometric symbol. This is where your geometric control is specified. 3. Diameter symbol, if required. If the geometric control is a diametrical tolerance, then the diameter symbol, O, will be in front of the tolerance value. 4. Tolerance value, the total tolerance of the geometric control. The unit of measure is based on the drawing standard. 5. The feature of size or tolerance modifiers, if required. This is where you call out any tolerance modifiers in the feature control frame. See the modifiers section of the GD&T symbols page for further clarification on these features. 6. Primary datum feature reference, if required. If a datum is required, this is the main datum feature used for the GD&T control. The letter corresponds to a feature somewhere on the part which will be marked with the same letter. This is the datum that must be constrained first when measuring the part. Note, the order of the datum is important for measurement of the part. 7. Secondary datum feature reference, if required. If a secondary datum is required, it will be referenced to the right of the primary datum feature reference. This letter corresponds to a feature somewhere on the part which will be marked with the same letter. During measurement, this is the datum fixated after the primary datum. 8. Tertiary datum feature reference, if required. If a third datum is required, it will be referenced to the right of the secondary datum feature reference. This letter corresponds to a feature somewhere on the part which will be marked with the same letter. During measurement, this is the datum fixated last. GD&T characteristics. Flatness. A condition of a surface having all elements in one plane. GD&T characteristics. Straightness. A condition where an element of a surface or an axis is a straight line. Straightness applied to a flat surface. The straightness of the feature must be within 0.003 tolerance zone. GD&T characteristics. Circularity, roundness. Describes the condition on a surface of revaluation, cylinder, cone, sphere, where all points of the surface intersected by any plane. GD&T characteristics. Cylindricity. Describes the condition of a surface of revaluation in which all points of a surface area equidistant from a common axis. GD&T characteristics. Orientation. GD&T characteristics. Perpendicularity. Perpendicularity is the condition of a surface, axis, or center plane that is a 90 degrees. GD&T characteristic. Angularity. Angularity is the condition of a surface, axis, or the median plane which is at a specified angle, other than 90 degrees, from a datum plane or axis. GD&T characteristic. Parallelism. Parallelism is the condition of a surface, line or axis which is equidistant at all points from a datum plane or axis. GD&T characteristics. Location. GD&T characteristic. Concentricity. Concentricity describes a condition in which two or more features, in any combination, have a common axis. GD&T characteristic. Position. Position tolerance define a zone within which the axis or center plane of a feature is permitted to vary from true position. GD&T characteristic. Symmetricity. Symmetricity is a condition in which a feature is symmetrically disposed about the center plane of a datum feature. GD&T characteristics. Runout. GD&T characteristic. Circular runout. From the desired form and orientation of a part surface of revolution during full rotation, 360 degrees, of the part on a datum axis. GD&T characteristic. Total runout. Total runout is a compound control that applies to all elements on surface of a part. As the part is rotation, 360 degrees, about the datum axis. Either around its datum axis or perpendicular to its datum axis. GD&T characteristic. Profile. Line profile, the outline of an object in a plane passes through the object. Surface profile is the result of projecting the profile of an object on a plane through the object at various intervals. Difference in flatness and parallelism. One common area of confusion within GD&T is between parallelism and flatness. With parallelism, a reference is made to a datum plane, while flatness is independent of a datum. Q&A, comment below. Thank you.